Welcome to the 3D printing portion of San Antonio College's 2020 3D Technologies Summer Camp. I'm your host, Aaron Ellis. In this session, we'll learn how 3D printers work. We'll also discover where to find files for 3D printing. And we'll learn how to repair the files and prepare them so that they can be used for printing. Finally, we'll learn how we can simulate 3D printing on our own, in our own homes, without a printer of our own. We can do this by using just a pencil, paper, cardboard, scissors, and some glue. So let's get started. As cool as 3D printing is, it's not magic. It works by separating complex models into simple slices and stacking them, one layer on top of another. If I gave you a ball of clay and asked you to sculpt the portrait of a celebrity, you probably couldn't do it. But if you traced 100 patterns on cardboard, cut them out, and then stacked them together, you could make almost anything you wanted. There are many different 3D printing processes. Some of the most important include FDM, SLA, LOM, SLS, and PolyJet. FDM extrudes a thin line of material, usually plastic, but also carbon fiber, concrete, and even chocolate. SLA solidifies patterns into photosensitive liquid resins using lasers or high-intensity light. SLS sinters or melts powdered materials like metal or nylon into flattened, curving shapes. And finally, PolyJet technology sprays a photosensitive resin into layered patterns. There are many ways to obtain printable 3D models, but some are better than others. Various free resources can sometimes provide great 3D models, but they might not always work with every printer. Thingiverse and GrabCAD are two good resources for obtaining 3D models. Paid 3D content from companies like Sketchfab or TurboSquid might work okay, but many times their models are designed for rendering or animation and may not work well for 3D printing. My favorite way to obtain 3D models for printing is to build them myself. This requires a lot more work than simply downloading a file from the internet, but it is much more satisfying. Before sending any 3D object to a printer, it is a good idea to check that model for broken geometry and repair any damage discovered. Once a model has been evaluated and readied for printing, it needs to be prepped, supported, and digitally sliced so that the printer can do its work. Each of the many brands of printers will have its own preparation software and slicing system. For our 3D printing summer camp activities, we will be simulating the LOM process mentioned earlier by tracing patterns onto paper, gluing them to cardboard, cutting out the contours, and then stacking them together. I've selected, prepared, and sliced a few example models for you to build at home. It's often a slow and somewhat tedious process, but if you've got the time and the patience for it, you can construct characters and monsters without spending a lot of money on 3D printers or supplies. Tracing, gluing, and cutting are all simple tasks, but it's important to make sure that you use cardboard with the appropriate thickness for the size of the contours you draw and cut. If the cardboard is too thick, your model will look stretched. If it's too thin, it will end up looking squished. The following examples show some pre-sliced and stacked models, as well as the stepped contours you will need to use to trace, paste, and cut to build your own models at home. That's it for our 3D printing introduction. If you have additional questions about how it all works or have trouble with one of the examples, let me know and I'll be happy to help.